Question 1. In the context of large commercial buildings with legacy pneumatic controls, Mr. Alston is troubleshooting a complaint where temperature zones are not responding to setpoint changes. He observes that the branch line pressure remains constant regardless of thermostat adjustments. Given this scenario, which of the following is the most likely cause of the issue? A. The actuator spring inside the valve terminal has broken. B. The main air supply pressure is fluctuating. C. The restrictor in the thermostat is clogged. D. The pneumatic thermostat is overcalibrated. Answer. Correct answer. C. Explanation. A clogged restrictor in a pneumatic thermostat will prevent proper modulation of branch pressure in response to setpoint changes. Without this restriction, the flapper nozzle mechanism can't vary the branch line pressure, causing static output. ANSI Standard 135 and HVAC Controls Handbook highlight that main air supply issues affect all zones, while a local restrictor clog isolates the fault. Actuator or calibration issues show different behavior than constant pressure. Question 2. By evaluating the behavior of a chilled water control valve which modulates to open as the space temperature rises, how should the thermostat controlling the valve be classified? A. Reverse acting. B. Modulating acting. C. Floating control. D. Direct acting. Answer. Correct answer. D. Explanation. A control that increases output valve opening as the input temperature increases is a direct acting control. This is commonly used in cooling applications. Reverse acting would decrease output as input increases. According to ISA RP.1 and RSES Control Fundamentals, understanding the interaction between the process variable and output signal defines the control type, modulating and floating signal form, not direction. Question 3. Considering the evidence in a schematic diagram, you notice a symbol representing a circle with a diagonal slash through it connected to a coil circuit labeled as SAR. What does this most likely represent? A. Solenoid coil. B. Transformer. C. Current relay. D. Normally closed switch. Answer. Correct answer. C. Explanation. The symbol, circle with slash, and the SAR label typically represent current relay coil. It's used to detect compressor current in HVAC systems. The diagonal slash indicates sensing function, and so is common designation in HVAC schematics. According to ANSI Point 2, now E315, accurate symbol interpretation is essential in identifying system functions and ensuring troubleshooting. Question 4. When faced with a refrigeration system that frequently short cycles on low pressure cutout, Ramirez observes that the system reaches cutout pressure too quickly after each start. What underlying control configuration issue should she investigate? A. Low pressure control is manually reset. B. The differential setting is too narrow. C. High pressure control is wide in series. D. The compressor is undersized. Answer. Correct answer. B. Explanation. A narrow differential on a low-pressure control causes short cycling because the cut-in and cut-out pressures are too close together. This doesn't allow the system enough time to stabilize. Per says a refrigeration controls manual and manufacturer application sheets, correct differential sizing ensures compressor longevity and reduces wear from excessive cycling. Other answers either misidentify the control function or symptom. Question 5. In light of recent developments, Mr. DeVore installs a air condenser fan motor to improve energy efficiency. After installation, he notices increased audible noise and occasional nuisance tripping of the motor overload. What is the most likely technical reason for this behavior? A. The motor is improperly grounded. B. The VFD is producing harmonics that the motor can't handle. C. The motor insulation has failed. D. The fan blade pitch is incorrect. Answer. Correct answer. B. Explanation. VFDs generate high-frequency switching ELR, which can cause harmonic distortion and voltage spikes. Older motors not rated for VFD may experience overheating, noise, and overload trips. E519 standards and NEMA MG1 Part 31 recommend using inverter-duty motors for VFDs. Grounding and blade pitch would affect other parameters, not the specific noise trip symptoms described. Question 6. Given the circumstances, a packaged rooftop unit shuts down immediately after startup. ISTA Santos notes that all safeties are wired in a series loop. Which of the following conditions would cause the system to fail to initiate correctly? A. Blower motor overload trip. B. Room thermostat is calling for heat. C. Outdoor fan contactor is open. D. Compressor capacitor is weak. Answer. Correct answer. A. Explanation. A trip blower motor overload opens the safety circuit, breaking the interlock loop and preventing operation. Safety interlocks like high limits, overloads, and pressure switches are wired in series to provide fail-safe protection. NEC Article 430 and RSES safety control references emphasize that all safeties must be closed to enable startup. Weak capacitors or idle contactors don't break circuits. Question 7. From a practical standpoint, low voltage wiring in a control system is routed near high voltage wiring inside a metal conduit. Later, Hysteresis notices erratic control behavior in thermostats and relays. What best explains the source of the malfunction? A. The control transformer is undersized. B. Ground loop interference is causing feedback. C. Inductive coupling from adjacent high voltage wiring. D. Poorly calibrated thermostats. Answer. Correct answer. C. Explanation. When low voltage control wiring is routed near high voltage lines, inductive coupling can induce unwanted voltage into the control circuit, causing erratic behavior. NEC Article 725 and E518 recommend separating or shielding low voltage circuits from power circuits. This is especially important in metal conduits where EMF interference is magnified. Transformer sizing, thermostat calibration don't cause such symptoms. Question 8. The fundamental question is, what distinguishes a snap-acting thermostat from a modulating thermostat in terms of control strategy? A. Snap-acting thermostats use electronic logic while modulating ones use pneumatic signals. B. Snap-acting provides on-off control or modulating varies output proportionally to temperature. C. Modulating thermostats only operate with VFDS. D. Snap-acting thermostats are only used in heating applications. Answer. Correct answer. B. Explanation. Snap-acting thermostats switch fully on or off at a set point, suitable for binary control systems. Modulating thermostats vary output gradually to maintain closer control of temperature according to ASHRAE fundamentals and RSES training texts. This difference defines system responsiveness. VFDS and application types don't determine thermostat classification. Both control types may be electric, pneumatic. Question 9. With respect to compressor overload protection, Mr. Chang installs a thermal overload device inside a scroll compressor. If the compressor fails during a brownout, what is the overload protection's primary function in this scenario? A. To trip instantly on voltage drop. B. To open the circuit once internal winding temperature exceeds safe limits. C. To disconnect based on refrigerant flow. D. To maintain the compressor running during undervoltage conditions. Answer. Correct answer. B. Explanation. Internal thermal overloads open when the winding temperature exceeds safe limits due to high current or voltage imbalance. During a brownout, low voltage increases current draw, potentially overheating the motor. Per NEMA and all 1995 standards, overload devices protect against thermal damage, not real-time voltage or flow monitoring. Instant trips and voltage tolerance are functions of other devices. Question 10. To illustrate this point, in a digitally controlled building automation system, BAS's fielding finds that one zone consistently overshoots set point despite correct PID parameters. What hidden issue should she investigate? A. Deadband setting is too wide. B. Control loop is improperly grounded. C. Sensor placement causes delayed feedback. D. The system is using floating point instead of integer math. Answer. Correct answer. C. Explanation. In digital control systems, sensor placement is critical. A sensor too far from the control zone causes feedback delay, leading to overshoot even with proper PID tuning. ASHRAE Guideline 13 and RSES materials stress accurate sensor positioning to prevent control lag. Grounding and numerical precision affect noise and speed, but not set point overshoot specifically. Question 11. Through careful analysis of the performance logs of A pneumatic system is Farrell notices a gradual loss of actuator responsiveness and slow return of dampers to their normal position after control changes. Moisture traps appear dry, but compressor run times are increasing. What is the most likely cause? A. The actuators have internal leaks. B. The air dryer is saturated and not removing moisture. C. The control lines are oversized. D. The compressor unloader is stuck closed. Answer. Correct answer, B. Explanation. The saturated air dryer allows moisture to pass through, which accumulates in the pneumatic system, causing sluggish actuator movement and poor control. Despite dry moisture traps, internal condensation can still occur. ASHRAE Guideline 15 and RSES materials emphasize clean, dry air as essential for pneumatic systems. Oversized lines and actuator leaks would present differently, and the unloader affects pressure regulation, not moisture removal. Question 12. Upon closer examination of a control circuit schematic for a two-stage heating system, Mr. Cruz notices a terminal labeled while feeding into relay coil that activates secondary gas valve. What is the function of the terminal in this configuration? A. It energizes the blower during heating. B. It provides emergency override for combustion air. C. It activates the second stage of heat upon demand. D. It controls the economizer damper. Answer. Correct answer, C. Explanation. In standard HVAC wiring schematics, the terminal is designated for the second stage of heating. It's energized when the first stage cannot satisfy the set point within given time or temperature delta. Per answer how HVAC control wiring standards and RSES fundamental deluentros stage of deluentros stage 2. Blower and economizer functions are controlled by different terminals G, O, or E. Question 13. The effectiveness of a normally closed solenoid valve used for hot gas bypass in a low ambient refrigeration application depends on which of the following operational factors. A. The voltage supplied must exceed 120% of rated core voltage. B. The valve stem must be manually opened before startup. C. The valve must be installed in a vertical position only. D. The coil must be energized based on suction pressure conditions. Answer. Correct answer, D. Explanation. In hot gas bypass systems, solenoid valves open when suction pressure drops below a set point, allowing hot gas to flow and maintain compressor load. This is a pressure-actuated control strategy according to the RSES service manual and valve manufacturer guidelines, e.g. Sporlan. Energizing the solenoid based on low-pressure signal prevents short cycling. Overvoltage and orientation limitations are not applicable in most standard solenoid installations. Question 14. Contrary to popular belief, simply de-energizing the disconnect switch is not sufficient when performing maintenance on a high-voltage rooftop HVAC unit. Mr. Burke is preparing to service a compressor contactor. What critical safety step must he take before touching the terminals? A. Turn off the room thermostat. B. Verify the power is off using a voltage tester. C. Remove the low voltage fuse from the board. D. Reverse the control transformer polarity. Answer. Correct answer, B. Explanation. NEC Article 110.9 and OSHA 1910.333 clearly require that verification of absence of voltage be performed before any contact with high voltage components. Disconnect switches can fail or be bypassed internally using a non-contact or contact voltage tester confirms actual de-energization. Thermostat and low voltage fuses don't affect line vol presence. Transformer polarity is unrelated to safety. Question 15. Throughout the course of testing, a defrost control system is Lang observes that the compressor continues to run during defrost even though the evaporator fan shuts off. What type of timer configuration does this behavior most likely represent? A. Time-initiated, pressure-terminated defrost. B. Demand defrost with adaptive logic. C. Time-initiated, time-terminated with compressor override. D. Hot gas defrost with fan delay relay. Answer. Correct answer, C. Explanation. In time-initiated, time-terminated systems with compressor override, the timer runs independently, but the compressor can continue operating based on system logic. This prevents capacity loss during defrost, according to the RSES control application manual and manufacturer timing diagrams. E. G. Paragon or Grasslin. This is a common configuration in medium temp cases. Adaptive logic. Pressure termination would stop the compressor under different conditions. Question 16. From multiple perspectives, the use of a control relay in a packaged HVAC unit can be justified in terms of signal isolation and load handling. Which of the following situations best illustrates this purpose? A. When controlling a 24 thermostat from a 120 main control board. B. When protecting the thermostat from vibration. C. When converting analog signals to digital outputs. D. When monitoring current with a shunt. Answer. Correct answer, A. Explanation. Control relays isolate low voltage control signals, e.g. thermostat from high voltage loads, e.g. motors, valves. This prevents damage and ensures safe signal handling. NEC 430 and RSES training materials emphasize relay use when switching voltage levels or current ratings exceed the signal source's capacity. Vibration and signal conversion are unrelated. Shunt monitoring in different components. Question 17. Examining the consequences of a miscalibrated pneumatic pressure sensor, Mr. Ortega discovers that space pressurization levels in a cleanroom are fluctuating outside of acceptable limits, which result is the most likely system response due to incorrect sensor calibration. A. Exhaust fans will increase speed continuously. B. The main air handler will cycle off prematurely. C. Return air dampers will fail to modulate properly. D. The space temperature will rise uncontrollably. Answer. Correct answer, C. Explanation. Pressure sensors in clean rooms often control return or relief dampers to maintain space pressurization. Miscalibration sends incorrect control signals, preventing proper damp modulation. ASHRAE Standard 170 in control logic documents emphasize accurate pressure sensing for contamination control. While fans may adjust speed, modulation failures more directly reflect sensor inaccuracy. Temperature is usually a separate control variable. Question 18. The predominant theory suggests that selecting a control strategy for a large variable or volume VEV system must prioritize which of the following to ensure energy efficiency and occupant comfort. A. Constant supply air temperature with fixed fan speed. B. Use of direct acting thermostats with large differentials. C. Sequence zone level control with demand-based ventilation. D. Maintaining static pressure with manual dampers. Answer. Correct answer, C. Explanation. Sequence zone level control with demand-based ventilation reduces energy use by matching ventilation to actual occupancy and controlling terminal units based on real-time feedback. ASHRAE 90.1 and 62.1 recommend these strategies for optimal HVAC control in modern buildings. Fixed fan speed and large differentials are inefficient and reduce comfort. Manual dampers cannot maintain static pressure precisely. Question 19. By comparing the output voltage of a solid-state ignition board during ignition attempts, Mr. Laird finds no output to the gas valve despite a 24th call from the thermostat. What conclusion can be drawn? A. The high limit switch is stuck closed. B. The flame sensor is contaminated. C. The control board has failed internally. D. The pressure switch is bypassed. Answer. Correct answer, C. Explanation. If the thermostat core is present but the ignition board doesn't output voltage to the valve, it indicates an internal failure. According to manufacturer diagnostics and the RSES electronics troubleshooting guide, the board's failure to respond means relays or logic circuits are damaged. Flame sensors only matter after ignition begins. High limit closed is normal. Bypassed pressure switches might allow operation lockout. Question 20. While it is true that pneumatic actuators can modulate precisely, which limitation must be addressed during their application in modern building automation systems? A. They cannot operate below 6 dielectric ambient temperature. B. Their response time is inherently slower than electronic actuators. C. They consume excessive electrical power. D. They are incompatible with the EDIs. Answer. Correct answer, B. Explanation. Pneumatic actuators respond via air pressure changes, making them inherently slower than electronic actuators. ASHRAE and RSES documents explain this delay can affect systems requiring fast feedback or tight integration with BAS. While still effective in many applications, Their response time and maintenance. Air leaks calibration can be a drawback. Temperature, power, and VFD compatibility are unrelated. Question 21. From a historical standpoint, building controls evolved from electromechanical devices to microcontroller-based DDC systems. Mr. Patel is upgrading an old HVAC system and notes that input points must be mapped for analog temperature sensors. What role does the microcontroller serve in this configuration? A. It replaces contactors in the motor circuit. B. It isolates control voltage from the load. C. It digitizes and processes sensor inputs to execute control logic. D. It boosts voltage to accommodate longer sensor wire runs. Answer. Correct answer. C. Explanation. Microcontrollers process analog and digital inputs to make control decisions based on programmed logic. For temperature sensors, the microcontroller converts analog voltage to digital values for control algorithms. Per ASHRAE Guideline 13 in the BACnet standard, input mapping, scaling, and logic reside within the controller's memory. Contactors and voltage isolation are unrelated. Signal boost requires separate devices. Question 22. In the absence of proper tubing support in a pneumatic control system, is Keating finds erratic pressure readings in branch lines. What is the most likely explanation for the control problem? A. The tubing material is too small in diameter. B. The thermostat calibration was skit. C. Sagging or pinch tubing has introduced flow resistance. D. The supply regulator is undersized. Answer. Correct answer. C. Explanation. Unsupported pneumatic tubing can sag or kink, introducing pressure drops or flow resistance, which distorts control signal timing and response. ASHRAE's pneumatic control design guides recommend securing tubing at regular intervals. Tubing size matters, but obstruction affects the signal more directly. Thermostat calibration and regulator sizing affect different aspects of system behavior. Question 23. To determine whether the burner limit switch is functioning correctly is to Book tests it under a simulated overheat condition and finds it does not open. What should he conclude? A. The limit is acting as designed to prevent shutdown. B. The limit switch is defective and must be replaced. C. The burner controller has overridden the limit. D. The flue damper is compensating for the excess heat. Answer. Correct answer. B. Explanation. A limit switch must open to interrupt the burner circuit when temperatures exceed the design set point. If it remains closed, it's unsafe and must be replaced. ANSYS point 20 and RSES safety protocols identify high limit switches as critical protection devices. Controllers don't override safeties, and flue dampers regulate combustion efficiency, not temperature limit safety. Question 24. The interrelationship between sensor signal quality and control precision is crucial in digital control. Mr. Green is diagnosing a bath that shows stable temperature readings, yet room comfort is poor. Which of the following could be contributing to the discrepancy? A. Sensor is calibrated but located in direct sunlight. B. Controller is in override mode. C. Actuator has a failed return spring. D. Supply fan has belt slippage. Answer. Correct answer. A. Explanation. Even calibrated sensors will give false readings if installed in poor locations. Like near sunlight, supply air, or electronics. ASHRAE 135 and BAS installation manuals emphasize environmental placement to ensure accurate sensing. Controller override affects control, not reading. Actuator and fan issues manifest differently, such as lack of airflow or mechanical noise. Question 25. During the process of commissioning a large control panel, Mr. Thompson finds that 24th control power intermittently drops when multiple relays engage. What is the most likely root cause? A. A relay coil is installed backward. B. The transformer is overloaded beyond its val rating. C. The control wiring is unshielded. D. The relays are being pulsed too quickly. Answer. Correct answer. B. Explanation. If several relays energizing simultaneously cause voltage drops, the control transformer is likely overloaded beyond its voltampere capacity. NEC 430.72 and RSES wiring guides emphasize calculating total coil draw and transformer sizing accordingly. Reversed coils and shielding affect signal quality, not power stability. Relay pulsing is controller issue, not issue. Question 26. While examining a refrigeration system, Sellers observes that a low-pressure switch trips even though suction pressure appears within normal range. What should she check first? A. The switch is set for cooling mode instead of heating. B. The sensing tube may be clogged or kinked. C. The ambient temperature is too high. D. The compressor relay is bypassed. Answer. Correct answer, B. Explanation. A clogged sensing tube can isolate the pressure switch from actual system pressure, causing false trips. According to RSES troubleshooting literature and manufacturer specs, always inspect tubing before suspecting the switch itself. Incorrect mode setting would affect thermostatic function, not mechanical pressure sensing. Ambient temperature affects load, not static pressure sensing directly. Question 27. The development of PID logic in control systems has enhanced stability and response. Istanovic notices oscillations in a heating loop despite accurate sensor inputs in the valve function. What PID component is most likely misconfigured? A. The proportional band is too wide. B. Integral time is too short, leading to wind-up. C. Derivative gain is 0. D. Sensor offset is negative. Answer. Correct answer, B. Explanation. A short interval time causes the system to overcorrect before the process stabilizes, leading to wind-up and oscillation. Ashura DDC guidelines advise gradual integration to prevent instability. Wide proportional band would reduce sensitivity. Derivative gain can stabilize, but isn't always required. Sensor offset affects accuracy, not loop behavior alone. Question 20. As a result of a power surge, Istali finds that multiple zone thermostats no longer control the relays they're wired to. He confirms power is present and wiring is intact. What internal damage likely occurred? A. Burned out heat, anticipators. B. Demagnetized bimetallic coils. C. Pitted contact switches from arcing. D. Loss of mercury bulb viscosity. Answer. Correct answer, C. Explanation. Arcing during a power surge can cause contact pitting in electromechanical thermostats, preventing them from closing or opening circuits properly. RSES diagnostic guidelines recommend visual inspection and replacement. Anticipators affect cycling, not contact integrity. Mercury bulb and bimetallic coil failures are rare and would show different symptoms. Question 29. Among the various calibration steps for a pneumatic thermostat, Mr. Waters is unsure why the branch pressure does not respond linearly to setpoint changes. What adjustment should he verify? A. The restrictor port is over-tightened. B. The span and setpoint scale are misaligned. C. The cover plate is not properly sealed. D. The return spring is undersized. Answer. Correct answer, B. Explanation. A misaligned span or setpoint scale prevents the thermostat from accurately translating setpoint to branch pressure changes. According to RSES and Honeywell pneumatic calibration manuals, verifying the mechanical linkage between the temperature setting and output response is essential. Restrictors and seals affect pressure, not response linearity. Question 30. With the advent of smart protection modules, ISTA Spivey installs a thermal overload relay with an automatic reset function. What safety risk must be evaluated with this configuration? A. The restart may occur before compressor pressures equalize. B. The compressor won't start without manual reset. C. The overload cannot sense phase loss. D. It increases locked rotor current during startup. Answer. Correct answer, A. Explanation. Automatic reset overloads can restart equipment without external confirmation that system conditions are safe. Restarting before suction discharge pressures equalize may cause damage. RSES electrical safety protocols and NEC 430 recommend caution when using automatic resets, especially in refrigerant systems. Manual reset prevents this. Phase loss detection is separate. LRA is startup specific and not controlled by the overload timer.